This is a demonstration of Labs 5.1 through 5.3, Changing Mixtures. Now, last time we looked at how some mixtures could be distinguished by the different individual properties of the substances in the mixtures. However, today we're going to look at how some mixtures can have entirely new properties based on what's been mixed together. Specifically, we're going to be looking at the properties of melting point and boiling point today. Here we are starting with 2 beakers of just plain ice straight from the freezer. Hopefully this is relatively pure water. And you can see it's right at the melting point now, because even though I only put ice in these beakers, some of it is starting to turn into water at the bottom. Think about what we've already learned about melting and boiling point this year as we look at these temperatures. This one looks to be about 0 to 1 degree Celsius. And we see the same thing here, maybe just slightly above 0 degrees Celsius. Does that fit what you already knew about the freezing point of water? Here's where we're going to introduce a mixture into this problem. I have here some rock salt. It's just some chunky salt, and I'm going to add it to one of these 2 beakers. Go ahead and pause the video and make a prediction. Do you think that a mixture of salt and ice will have an effect on this temperature or this freezing point? Write down or type what you think that effect will be. All right, I'm going to stir around the ice and salt until I know it's well mixed. And I'm going to leave it for a few minutes just to let the new temperature show up on the thermometer. All right, it's been about 2 or 3 minutes just to let our thermometer change. And already I'm making some observations. I can see that the mixture of salt and ice or salt and water is a bit cloudier looking. There appears to be a bit more water as opposed to this beaker that just has ice and water in it. But let's look at the temperatures. Here, it looks like the temperature is just between, let me turn it, 0 and -1 degree. A second ago is between 0 and 1, so it's hovering right around 0. It hasn't changed a whole lot. On this side, however, let's see, here's 10 degrees, here's 0 where it was, and now it's 5 lines below that. Our salt and ice mixture is at -5 degrees, and it looks like it may even still be dropping. Go ahead and pause the video here and write down your best attempt at an explanation. Why is this mixture of salt and ice colder than just the ice? All right, so now we're gonna look at the flip side of this. Again, I have a beaker of what is hopefully pure water. I got it out of my sink here in the lab, and I've just brought it up to a boil with one of these burners. Think about what you know already about the boiling point of water as we look at the temperature. It does look like it's right around 100 degrees Celsius. Does this fit what you already knew about the boiling point of water? Just like with the ice and freezing point, I'm going to add some rock salt now to this water, and we're going to see if it changes this temperature or this boiling point at all. Okay, it's been about 2 or 3 minutes, just long enough for all of the salt to dissolve and it to start boiling again. Let's look. The mixture looks fairly similar. It still looks like a clear boiling liquid. But if we look at the temperature up here, it's now reading, what is that, like 102, 103 degrees Celsius? The temperature has raised slightly from when we were boiling pure water. Go ahead and pause the video and write down, why do you think that is? For our third and final part of this experiment, I wanted to look at a mixture that might be a bit more unconventional. Here I have 3 pieces of solder. Now solder is just a small piece of metal that is actually a mixture of a few different metals. It's an alloy, and it is designed to melt at a fairly low temperature. Solder can be used to sort of like weld things, maybe on a circuit board. You may have seen it doing some small projects around your house before. Now, I have 3 totally different pieces of solder here. They've been color coded. This one's colored red and green. I think the back side of this one is blue. And they're color coded to remind me that they're different, because each of these are actually slightly different mixtures of metals that give these different pieces of solder different properties. We're going to look at one of those properties now, the melting point. Just so you can see the full apparatus here, I have a burner. It's actually the same burner I was using to boil the water a second ago, with the tray of solder pieces just above it. Now that it's lit, we're going to make sure it's centered on it. We're going to keep a really close eye on these. I see the red one changing very quickly. It's possible the blue one has also changed. Oh wow, look at that color. Compared to the red one, which is changing all sorts of colors, and the blue one, which appears to maybe have melted, our green one looks fairly unchanged. And see, if I poke this, we have an entirely liquid metal here. Three entirely liquid metals. What's interesting to me is that the way all 3 of these became liquid, the time at which they melted, and the way they looked when they melted were all different because of the difference in the mixture that composed them.